Dear students, good morning. In the previous video, that is determinant part 8, we solved some problems in the exercise 4.2. Okay, now expansion of a determinant without expansion by using the traditional method, not by using the traditional method, by using the properties we have to solve. It is important one. Important, very important one. Essay questions will come. So we have to concentrate on solving the problem. Okay, now it is a standard methods are there. We have to follow that one. Number of times you practice it well. Otherwise it will not come. Okay, now be careful. Now already I solved up to 10. Roman 1 is given as homework and Roman 2 is solved in the previous part 8. Now it is part 9. It is the 11th one. In the 11th one, 1 and 2 problems are very important. 2 problems I will solve it. First one, LHS. A minus B minus C. You see, A minus B minus C, 2A, and something is there. Here, in order to make A, B, C, A minus B minus C as A plus B plus C means, you simply add the row 2 and row 3. Minus B plus 2B plus B. Minus C plus 2C plus C. Okay, na? So, it will be. So, I am applying row 1. It is becoming as row 1 adding with row 2 and row 3. Okay, na? So, as I said, here it is minus B plus 2B plus B. Minus C plus 2C plus C. Here also 2A minus A. We have to add this row 2 and row 3. 2A minus A is plus A, plus B is there, 2C plus minus C into plus C means. Okay, now here also 2A minus A, 2B minus B, B plus C. Okay, now and the remaining 2 rows as it is. But here in the first row, you see, first row a common is there. A plus B plus C is the common in the first row. So after taking the A plus B plus C as common in the first row, we have 1, 1, 1 in the row 1. The remaining as it is. Okay, now remaining is as it is. Now, already I told you, in the determinant, if 1, 1, 1 is there, a row or in column, you make it as 0. 0 means, making 0 means instead of deleting the 1, erasing the 1 and putting 0, no, not that one. C2 minus C1. 1 minus 1 is 0. 1 minus 1 is 0. So, I am applying C2 minus C1, C3 minus C1. Now it is column 1 is as it is, 1, 2B, 2C. 1 minus 1 is 0. B minus C minus A minus 2B. You see, Nana? B minus C minus A minus 2B. That is minus C minus A. B minus 2B means minus B. So, there is a minus as common. Okay, now? So, minus B minus C minus A. Okay, now? Again, 2C minus 2C is 0. And similarly, 1 minus 1, 0. 2B minus 2B is 0. Now, this is C minus A minus B minus 2C. That is minus A minus B minus C. C minus 2C means minus C. So, I write this one. And again, you observe me. Observe me. Here in the column 2, 0, minus of, if you write it as minus of A plus B plus C, 0, minus of A plus B plus C, 0. So, A plus B plus C with minus is common in the column 2. In the column 3 also, 0, 0. 0 means it is a common, any factor is included in it. 0 and anything is 0. 0 and anything is 0. Here also minus of C plus A plus B, or otherwise minus of A plus B plus C is common. So in the C2 and C3, I took the common as minus of A plus B plus C. Minus of A plus B plus C. Very clearly right here. Already a plus b plus c is common is there. After taking common minus of a plus b plus c in the C2 and C3, we get 1, 2b, 2c is as it is, and 0 minus, here not minus 1, totally I took the common. So 0, 1, 0, 0, 0, 1. Okay na? Now, it is very simple. Now this is minus into minus plus a plus b plus c, a plus b plus c, a plus b plus c whole cube. This is 1 of 1 minus 0. Okay na? Minus 0 and anything is 0, plus 0 and anything is 0. So we get here it is only one expansion of the determinant in the determinant row 1. The row 1 I am expanding the determinant. Why? Because up to this one, this is the last step of the determinant. After this one, it is not possible to use any property. There it stops. So there we have to apply the expandation. So 1 of 1 minus 0, minus 0 and anything is 0, plus 0 and anything is 0. Calculation in the first row. So it is only 1. 1 and anything is something. So a plus b plus c whole cube. That is what we are required to find RHS. Okay na? Go like this one. It is important one. Try to understand it. Yeah. Okay students. Now the 11th problem, first one is solved. The second 12, 13, 14. These are very important problems already asked in the previous exams. Okay na? Right. Okay na? See. 11th, Roman 2. LHS x plus y plus 2z xy, the same. Now, you see that it is standard steps are there. Just a logic is there. X, y, 2z is there. If you add for C1, C2, column 1, column 2, it will become as 2x. Column 3 become as 2y. So 2x, 2y, 2z. Here also if you add z, 2z, 2x, y plus y, 2y will come. Okay now? So applying C1 as, it becomes as C1 plus C2 plus C3. Then it will become as 2x plus 2y plus 2z in all the 3 elements. Okay now? And it is a second row, a second column and a third column as it is. No change at all. But here 2 of x plus y plus z is taken as common in the first column. So there remain 1, 1, 1 and the same steps will be same. It will not be changed. One element 1, 1, 1, 1 is there in the first column. If 1 is there, we may reduce as 0. How? R2 minus R1, 1 minus 1, R3 minus R1. So R2 minus R1, R3 minus R1. So the first column is, first row is as it is. That column is okay. 1 minus 1 0. Okay na? Y plus z plus 2x minus x. We get plus x plus y plus z only. Y minus 1 is 0. Here also 1 minus 1 0, x minus x is 0, z plus x plus 2y minus y, R3 minus R1, 2y minus y, y remain. Okay na? Again you see in the column, in the row 2, x plus y plus z, because in the 0 x plus y plus z is common, here also common. Here also in the third row also x plus y plus z is common in the first 2 elements. So there remain, you see then, x plus y plus z is taken as common. Again in the row 3 x plus y plus z is common. So 2 times we are taking that factor. Already 1 time is there, 1, 1, 1. So cube will form. So 2 of x plus y plus z whole cube. Okay na? And there remain 1, here x, y. Here 0, here 1 is 0, 0, 0, 1 only. Now, by expansion, it is the last step, ultimate step in the determinant. There is no other step. up to that one, and not possible to apply any property. So 2 zeros will come. Okay now. So now need to apply any row method. It is over. Now expansion in the first column. 1 of row column, 1 of 1 minus 1, 1 minus 0, 1 only. Minus 0 plus 0 will come. So in the expansion we will get the expansion of determinant is 1. 1 into anything is 0. Anything is that thing. So we get that this is RHS. Okay now? RHS. Okay now? Right. Like that we have to solve. 2 of x plus y plus z is whole. Okay now? Yeah. Okay. 12th one is also important problem. All these problems are important. Already asked in the exam. 12th one. LHS 1x x square 1x x square 1. Okay now. Here I want to make a common. You see, R1 added with R2 and R3. R1 plus R2 plus R3. That R1 becomes as like that. 1 plus x square plus x. In order 1 plus x plus x square. Here also 1 plus x plus x square. 1 plus x plus x square. In the first row. Yeah, okay. And as it is, the remaining no change at all. R2 and R3. So in the first row, 1 plus x square is common, taken as common. Then we remain 1, 1, 1 only. Okay now? Second one, third row as it is. But the thing is, we get 1, 1, 1 in the first row. So in order to make 2 zeros, R2 minus R1, R3 minus R1. Okay now? Not C1. C2 minus C1, C3 minus C1. Okay now? No confusion. And the first column is as it is. That common is okay. 1 minus 1 is 0. And 1 minus x square minus x. Be careful here. And again 1 minus 1 is 0. X minus x, x minus x square is okay. And 1 minus x. Okay now? Like that. Now, the common is as it is 1 plus x square. You see, here in the second row 1 minus x square means 1 plus x of 1 minus x. X minus x square is x as taken as common, x of 1 minus x. Okay na? Here also in the third row, x square minus x means x of x minus 1. And it is 1 minus x as it is. Now you see, don't confuse me. This is second column, 0 and something and something. In this one, 1 minus x, here also 1 minus x is common is there. In the 0 also 1 minus x is common. So I took 1 minus x is common. Here also 0, 1 minus x, here also 1 minus x. I take the 1 minus x as common. Now there remained the first column is no alter as it is. The second column 0, 1 plus x only. 1 minus x is taken as common. And here x of 1 minus x not there. X minus 1 is there. If you change 1 minus x, we get minus. Be careful. And here it is 0, here remain 1, here is x, here is 1. Okay now? Now, this is the thing. Just observe it. Just I will. You see, the top. Okay. The same steps. It is 1 plus x square, and it is 1 minus x of 1 minus x. Now it is so okay. In the ultimate determinant, ultimate step in the determinant. 1, 0, 0 is there. So into 1 of, I am calculating the determinant in the first row. 1 of, generating the first row, first column. These are the elements. This is 1 plus x into 1 is 1 plus x minus of minus x into x. Try to understand. Minus of minus x into x. That is plus x square. Okay na? Yeah. Now it is 1 plus x plus x square 2 times there, and 1 minus x 2 times. It is 1 plus x square of 1 minus x whole square is there. Okay, now a minus b of a square plus b square is similar. 1 minus x 1 square 1 into x plus x square is there. Total square is there. Okay, now a minus b is just like a minus b of a square plus ab plus b square. Okay, now this is nothing but a cube minus b cube. Like that it is 1 cube minus x cube. Total square is there. That is simply 1 minus x cube whole square. Okay, now that is nothing but RHS. Like that? Yeah. Right, like that. Okay, 13th problem. 13th, you see, it is somewhat different type. Observe it. LHS 1 plus a square minus b square is there. 2ab minus 2b. 2ab 1 minus a square plus b square. Here you see in the third row 1 minus a square minus b square. When we feel that it is some wrong, but it is a correct one. Observe me. Here is the standard. We have to take like this one. The row 1 will be changed as R1 plus B into R3. Up to now, we are applying R1 minus R2, R3 minus R1, C1 minus C2 like that. Here only with a multiplication of B, R3 is added to R1. With a multiplication of A, R3, multiplication of R3 with A, we are subtracting from R2. Okay, now it is a different type of problem. Why? Because you see R1 is changed as R1. You multiply R3 with B first and 2B square. Okay, now and it is added to R1. Here R1 minus B square. This is 2B square minus B square plus 2B square. Minus B square plus 2B square means B square only. Here 2ab with minus 2a, already b is there, multiplication of b. 2ab minus 2ab, we get 0. Be careful. Similarly here also 2b minus 2b is there and we are multiplying with b. I will write here. Please try to understand. Minus 2b is there, R2, R1. That is added with B into R3. That is B into R3. Okay, na? Like this. So minus 2B. This is B minus, or otherwise we take B as common. We will take B. Minus B as common means it is minus 2 plus 1. Minus a square minus b square. Okay, na? B of minus 1 minus a square minus b square is there. Take minus b as common. It is 1 plus a square plus b square is there. Be careful. Okay, na? That much of work is there. It is separate. You have to work and put it at once only. So it is minus b of 1 plus a square plus b square. Okay, the first one is correct. Here 2ab. Here also multiplying with the b. Minus 2ab plus 2ab cancels 0. Here also very simple. Minus b square is there. This is 2b square. Minus b square plus 2b square. We get a plus b square. Okay, now like this R2 also it is changed as R2 plus R2 minus AR3. Here also, this is R2 na, with A, we are multiplying. R2 is there, 2AB, minus, we have to take minus A into, that is 2AB. So we get 0. And here it is 1 minus A square plus b square is there, and with minus 2a square. Okay, now this minus 2a is multiplied with the minus a, so it is plus 2a square. So 1 plus a square plus b square. Be careful. So that is the thing. Next again here also observe me. Here 2a is there minus a of 1 minus a square minus b square. You take a as common. This is 2 na, minus 1 na, plus a square plus b square. Okay na? 2 minus 1 is 1 plus a square plus b square is there. Okay na? Like this. Here it is. So row 1 and row 2 are completed. Now you see, in the row 1, in the row 2, 1 plus a square plus b square is common. In the row 1 and in the row 2. So there remained 1, 0, minus b, 0, 1, a, and third row is as it is. No change at all. Okay, now? But this is ultimate. After this one, not possible, because in the determinant 2 zeros are there. Okay, it is enough. Now directly we will calculate. Here 2 factors. Double time is there, so square is there. 1 plus a square plus b square whole square. Here 1 off. I am expanding the determinant in the first row. Okay, now? First row or first column? First row only. 1 off row column is deleted. 1 off this one, then 1 into something is same thing. Okay, now? Minus 2a into a plus 2a square. Be careful. Okay, now? Minus 0 in anything. 0 into anything is 0. No need to write. Plus minus b into plus minus b, that is minus b of row column is deleted. Now these are the elements. 0 minus 2b into 1 is 2b. Okay, now? After the simplification, we get the same. After simplification, very simple. 2a square minus a square minus b square. Here it is plus 2b square b square. Again we get one more factor. If 2 times is there, 1 time. So it is a cube. 1 plus a square plus b square whole cube. That is a RHS. Okay, now? Now, that is 13th problem. Now you see 14th problem. Observe it. LHS. It is a square plus 1 AB, AC. Something is given. Okay, now? It's somewhat logic is there. Try to understand. Some logic is there. In the first column, I took A as common. A is there. Here in the second column, B is there. In the third column, C is there. Okay, now, if you take A as common in the first column, A square means A. Here no A at all. So 1 by A I wrote. Don't confuse none. If you multiply A square, 1 by A into A is 1 only. I am taking A as common here. And in AB, B is remained, A taken. And CA, A is taken as common, then C only. In the second column also, B taken as common. Here A remained, here B square means B plus 1 by B. Try to understand. And CB means C only. Here also, C taken as common. AC means A, BC means B, C square means C, 1 means 1 by C. Okay, now? Now, here is somewhat a logic case. As we are taking A from column 1. Now I am sending A to the row. Taking common from column 1 and now multiplying with that A in the elements of first row. You see, A into A square. A into 1 by A only. A into A is A square. A into A is A square. Don't confuse. Once again I want to tell. In this LHS, in the first column I took A as common. Okay now? By taking, you see, don't confuse. A square plus 1. If you take A as common, A plus 1 by A. Very simple. So I took A as common in the first column, B in the second column, C in the third column. We get this one. Okay. A, B, C are the common terms. We take C1, C2, C3. Now I am multiplying again. A multiplies the elements of row. It is come from column 1, but now it is again going inside the determinant and multiplies the elements of A1, I mean R1, row 1. So A into A square. A into 1 by A, 1 more. Again A into A square. A into A square. Okay, now B into second row. B into B, B square. B into B, B square plus B into 1 by B is 1. Again B into B, B square. Similarly, C in the third row, C square, C square, C square plus 1 by C into C is 1, 1. Okay, now? We are taking A in the first column, but again multiplying in the first row. Taking B in the second column, multiplying in the second row. C in the third column and multiplying the third row. Okay now? We are taking A, B, C as common and again multiplying. Taking from determinant and sending into determinant. It is just like, it changes like this one. It's a fantastic concept. Now, I am applying, you see, R2 plus R1 plus R3. Okay now? R2, it becomes as R2, R1 plus R3. R1, it is this R1, it is R2. We are applying. Simply, you add for R1. 1 plus A square plus B square plus C square. Here also 1 plus A square plus B square. 1 plus A square plus B square plus C square. Okay, now the remaining rows as it is. Now we get 1 plus A square plus B square plus C square as common in the first row. So taken 1, 1, 1 remained. Okay, now if 1, 1, 1 is there in a row or in any column, you see C2 minus C1 we get 0. C3 minus C1 we get 0. Number of times we solve this type of problems. Here it is B square plus 1 minus B square, 1 remain. B square minus B square, 0 remain. C square minus C square, 0 is C square plus 1 minus C square is 1 remain. The first column is as it is. It is the application. Now by expansion, it is okay. The expansion now, it is ultimate determinant. There is no way to apply any property. It is simply the last one. So now expansion in the first row. 1 of 1 minus 0. Okay, now minus 0 is nothing. That is nothing. 1 of 1 minus 0. Minus 0 to anything is 0. 0 to anything is 0. It is 1. 1 in something is something. So that is the RHS. Okay, now. Like that we have to solve. It is over. 15, 16 is very simple problem. You solve it.